The application layer. This is the only layer that interacts directly with the user. The application layer provides the interface for the software you use to communicate with the network. It is not the application itself, but the protocols that the application uses. Think of web browsers using HTTP or HTTPS, email clients using SMTP for sending emails, or file transfer programs using FTP. Its job is to present data in a way the user's application can understand. The presentation layer. This layer is the translator for the network. It takes the data from the application layer and converts it into a standard format that can be sent over the network. Its primary jobs are data formatting, character encoding, compression, and encryption. For example, when you connect to a secure website, the presentation layer is responsible for handling the SSL and TLS encryption and decryption, ensuring that your data is protected and unreadable to anyone eavesdropping. The session layer. This layer is the conversation manager. Its job is to create, manage, and terminate sessions or communication channels between two devices. It acts like a dialogue controller, ensuring that the connection between the sender and receiver stays open long enough to transfer all necessary data, and then closes it to free up resources. It also handles things like authentication and determines whose turn it is to talk. The transport layer. This layer is responsible for end-to-end communication and data integrity. It takes the large chunks of data from the session layer and breaks them down into smaller segments. It then has two main ways of sending them. The first is TCP, the Transmission Control Protocol, which is connection-oriented. TCP numbers each segment, ensures they all arrive, and reassembles them in the correct order, resending any that get lost. The second is UDP, the User Datagram Protocol, which is connectionless. UDP is faster, but less reliable. It sends the data, but doesn't check if it all arrived, making it ideal for video streaming or online gaming, where speed is more important than perfect accuracy. The network layer. This layer is the network's traffic controller, or GPS. Its job is to move data packets across different networks, a process known as routing. The network layer uses logical addressing, which we know as IP addresses, to determine the best path for the data to travel from the source computer to the destination computer. Routers operate at this layer, making decisions about where to send your data next so it can reach its final destination, even if it's on the other side of the world. The data link layer. This layer manages communication between devices on the same local network. It takes the packets from the network layer and packs them into frames. The data link layer is responsible for two key things. First, error detection and correction for the physical connection, and second, physical addressing using MAC addresses. A MAC address is a unique hardware identifier for a device's network card. Network switches operate at this layer using MAC addresses to forward frames only to the specific device they are intended for on the local network. The physical layer. This is the lowest layer of the OSI model, and it's all about the raw, physical connection between devices. This layer includes all the hardware that makes communication possible. The cables, such as Ethernet and fiber optics, the radio waves used for Wi-Fi and Bluetooth, connectors, and network interface cards. Its job is to take the digital ones and zeros from the data link layer and transmit them as a physical signal, whether that's an electrical voltage, a pulse of light, or a radio wave. It is the foundation upon which all other network communication is built. Thanks for watching. Which topic would you like me to cover next? Let me know in the comments.